Hello, everybody. And here we go with lesson 1 of Unit 8. Now, Unit 8 is covering radicals. Radicals is one of those things that will go with you to the next class. Actually, I teach the next class, geometry. We're actually using these a lot right now in the unit that we're doing in geometry. So, and I know they are used a lot in Algebra 2. So this is your first experience with them. You may have seen them before, but don't really know what they mean. So today, we're just going to focus on simplifying radicals containing numbers and the product of radicals, okay? Where does a radical come from? Well, you've seen x squared before, and you'll see equations where it says x squared equals 50. To solve that equation, x squared equals 50, we need to get rid of the exponent, right? That's how you're going to get x by itself, is you got to get rid of that exponent, okay? How do we do that, though? It's not a 2. It is a 2, but it's not like a 2x. You can't just divide by 2. You need to undo the squared term. And to do that, you have to use the square root. This is what I was saying. You've probably seen the square root and maybe even dealt with a little bit of the square root, but you've barely been introduced to it. All right. That square root symbol is also called a radical. A square root is just a specific type of radical. Okay. It's the only one we're going to really deal with in this unit this year, but it is a radical. Just like addition undoes subtraction and division undoes multiplication, taking the square root of a squared number undoes the squared term. Okay, an example of that, I have a couple examples of that. So if I have the square root of 13 squared, you're going to take, and the square root and the squared are going to cancel, and you're going to be left with 13. You can probably guess what you're going to have when you take square root of 7,148 squared. You're going to get 7,148. And that property right there will get used later on the back side of the notes. So hold on to that. All right. For now, I'm going to stop that and move on. So to solve the equation from the beginning, x squared equals 50, we would take the square root of both sides. Well, what does that do? The square root and the squared exponent cancel. And we are left with just x. We've now solved for x. We've gotten x by itself. But what it's equal to is the square root of 50. And the square root of 50 is not in simplest radical form. You'll see me say this a lot. You'll see it written a lot. Simplest, put your answer in simplest radical form. You don't know what that means yet. That's what we're going to work on today. All right. And before I can do that, I need you to see a property of radicals. So the property is right here, which is the square root of a times the square root of b equals the square root of a times b. So all that's saying is if you're multiplying, not adding, not subtracting. If you are multiplying two radical expressions together, you can just multiply the two things under the radical together to make one radical expression. Basic example of that is right there. Square root of 12 times the square root of 3. I can put 12 and 3 together and just multiply them and say 36, which helps me here because what's the square root of 36? A lot of you know that. It is 6. Okay. That's one of the properties of radicals that's going to be helpful. The reverse of that property is also true. What I mean by that is the square root of AB. If I start with an expression, I can split that into two separate radicals. So I can go the other way as well. And that leads to prime factorization. Okay. Prime factorization is one of two methods that I know of for simplifying radicals. You may have done prime factorization before. If you haven't, I'm going to do it here several times. Okay. If you want to see the other method, I can show you. I'm not going to do it in the notes. We're going to do the prime factorization of 50. What does that mean? Well, I'm going to break that down into all of its prime factors. Factors are two numbers that multiply to give you, in this case, 50. It can be any combination except for 1. You can't use 1 and 50 because then you didn't really get anywhere. And basically, I want to break this down. So I see 5 and 10. You could also say 2 and 25. It doesn't matter. Okay. I'm going to circle any of those, either of those two numbers that's prime. 5 is prime. I can't go any farther than 5. The only two numbers that go into 5 are 1 and 5, and I just said you can't use 1. So 5 is done. I circle it. 10 can go a little further. 10 is 2 and 5. 5 is prime. We already talked about that. 2 is also prime. The only two numbers that go into 2 are 1 and 2, so it's done. Once you've gotten all of the numbers down to their prime factors, you've done the prime factorization of that number. So the prime factorization of 50 is just the 3 circled numbers. So 2, 5, and 5. Okay, so that's the prime factorization of 50. And notice that they're all, if I just multiply 2 times 5 and then multiply that answer by 5, I'm going to get right back to 50. Let's do 120. You could do any two numbers that multiply to give you 120. If you're not sure what they are, well, I see that 120 is even, so I can know 2 goes into it 60 times. 2 is prime. 60 keeps going. I'm going to go with 10 and 6. Neither one of those is prime, so I'm not done with either one. 10 is 5 and 2. 2 is prime, 5 is prime. 6 is 3 and 2. Okay, I have 5 circled numbers, and now I'm going to write them. I'm going to put them in order. So there's 3 2s, and then a 3 and a 5. And if you want to check to make sure you did it right, just multiply those 5 numbers together. You should get 120. So that's prime factorization. Okay, now we're going to put everything here on the front together on the back. How does prime factorization and everything we've talked about apply to radicals? Well, we were doing the square root of 50, right? I'm going to rewrite that as the square root of its prime factors. So it's 2, 5, and 5, right, from the front. So I've got 3 numbers being multiplied together here under one radical. The property that I showed you on the front side says that I can now break that into 2 or more radicals. And I'm actually going to just break it into square root of 2. And then I'm going to do the square root of 5 times 5. Why am I keeping the 5s together? Because of the very first property I showed you. So square root of 2, nothing happens. I'm just going to leave that alone. 5 times 5, yes, is 25, but I could also write that as 5 squared. Remember on the front, the very beginning, when I said the square root and squared undo themselves? So what I've done here is I've gotten a squared and a radical, and they cancel, and I'm left with a 5, no more, and it's not covered by a radical anymore. And then the radical 2 goes at the end, and that is the simplified version of the square root of 50. Okay, I know it's probably a little confusing right now. We're going to do this quite a bit in these notes and in the future. So we'll do another one here with 120. We already did the prime factorization. It was 2 times 2 times 2 times 3 times 5. And then I'm going to do something here. I only want 2 2s. And then I'm going to put a 2, a 3, and a 5 in their own radicals. Why? What exponent do I want inside the radical? I want an exponent of 2. And if I put all 3 2s in the same radical, it's going to be an exponent of 3. I don't want that. So this becomes 2 squared, and all the other ones just stay as radicals. And so what happens is the radical and the squared cancel, and that leaves me a 2 on the outside of the radical. So it's no longer under a radical. And then 2, 3, and 5 are still under the radical. So what I can do is I can just actually put those all back together. Basically the property that I showed you at the beginning going in the right way. So 2 times 3 is 6, 6 times 5 is 30. Put those all back together and make 30. And that's the simplified version of the square root of 120. Okay. Got 3 more here, and then more after that. So simplify each radical expression. This is what you're going to have to do on your own in class. So square root of 48, I'm going to break that down. So I'm just going to go ahead and break it down right now as underneath the radical. So 2 numbers that multiply to 48 that are not 1. So I'll say 4 and 12. 4 is not prime, so it's 2 and 2. 12 is 2 and 6. And 6 is 2 and 3. So square root of 48 is 1, 2, 3, 4 2's and an extra 3, all under the radical. So now what I'm gonna do is I'm gonna split that into pairs, right? Put 2 2's under one radical. I'm gonna put 2 2's under another radical. And then the 3 is gonna be all by its lonesome. All right, so I'm gonna have the square root of 2 squared, the square root of 2 squared, and the square root of 3 all by itself. Radical and the squared cancel, I'm left with a 2. Radical and the squared cancel, I'm left with another 2 that I multiply together. Square root of 3 just stays there. So that's 4 radical 3 is my answer on that one. Okay, I'm doing all the work so that you can see why I'm getting what I'm getting. I'm going to show you a quicker way to do it. But before I show you that quicker way, I want you to see why it's working. And that's why I'm going through all this work. Okay, so square root of 30 is 10 and 3. 3 is prime. 10 is 5 and 2, both prime. So I have 2, 3, and 5, right? Well, what happens here? I don't have any that I can make an exponent of 2 with. If that happens, where you don't have any that you can make an exponent of 2 with, you just multiply them all back together. That one was as simple as it could go. You couldn't break 30 down anymore. Okay, we'll do 16, 4 and 4, 2 and 2, 2 and 2. So that's 4 2's. I'm going to break them into so I can make pairs. So that's 2 2's under one and another 2 2's under another. So that's 2 squared and 2 squared. The radical cancels. That's a 2. Radical cancels the squared. That's another 2. 2 times 2 is 4. There's no numbers left under the radical. It's just 4. You should have known that actually too. What's the square root of 16? A lot of you already knew that. It was 4, but that's why it's a perfect square, because there's nothing left underneath the radical. Okay. Almost done with this one. I'll do a summary here. When simplifying radicals, we look for pairs of the same numbers under the radical sign. Why? Because if they're a pair of the same number, you're multiplying together, you can write them as that number squared, and then that cancels the radical, and you bring that number out. Okay, these can then be simplified, and a number can be brought out from underneath the radical sign. Anything that is unpaired is left under the radical. So I got a few tougher problems here that we're going to go through here. So 8 radical 27. There's an 8 on the outside of the radical. A lot of people have a hard time with that. They try to break down the 8. Don't do that. That 8's already outside. And now basically what's going to happen is I'm going to focus on just the square root of 27. I'm going to do that right over here. And that's 9 and 3. And then 9 is 3 and 3. And then that's a pair of 3s. So I'm not even going to do all the work that I did on the previous problems. A pair of 3s. I'm looking for 2 of the same number. That's going to make a 3 on the outside. So it's 3 with 1 left over 3. Now I did that very quickly. Keep in mind what I did there. A pair of 3s can be rewritten as 3 times 3, which is 3 squared. And that cancels, and I'm left with just a 3. So 2 3s made a single 3 on the outside. And there was that leftover 3 here that got put back underneath the radical. So that's why it's 3 radical 3. Now that 3 gets multiplied by the 8, and I get 24 radical 3. Okay. Number 2, square root of 5 times the square root of 8. That's 2 numbers under the radical, and I'm multiplying them. I'm going to put those together and make 40. And then I'm going to break that down. 4 and 10, 2 and 2, 5 and 2. And you're probably noticing my handwriting is terrible at this point. And I guess it's a good time to talk about, make sure you can read your own handwriting. If you can't read it and you get down to the end and you're like, I don't even know what those numbers are, you're probably going to get the problem wrong because you are going to read your numbers wrong. Now, I know that this is a pair of 2s, so that's a 2 on the outside. and then 5 and 2 are not paired. So I got to put those back underneath the radical. And I'm going to go ahead and multiply those together. Don't add them. 5 and 2 makes 10. It's 2 radical 10. Okay. In the one we just did, we combined the 5 and 8 to make the square root of 40. We were allowed to do that since both numbers were inside the radical. We can also combine numbers that are both on the outside of the radical, which is kind of what I did here. Those are outside the radical, so I combined them to make 24. The only combination we cannot make is a number on the outside of the radical with a number on the inside of the radical. I cannot put those together. Notice I did not, on number 1 up there, I did not do 8 times the inside 3. I just did 8 times the outside 3. Okay, that's what that's getting to. All right, 4 more, and then we'll be done. I know it's a little bit long here. 9 is on the outside of the radical, 14 is on the inside, so I cannot put them together. I'm actually going to write the 9 on the outside, and now I'm going to try and break down 14. So 14 is 7 and 2, right? There's no pairs there, so they just go right back into under the radical and make radical 14. I can't simplify that one at all. So it's 9 radical 14. Okay, number 4 here. I've got numbers on the outside, 6 and 3, and I've got numbers on the inside, 2 and 50. I'm going to multiply what I can multiply together. So 6 and 3 makes 18. 2 and 50 makes 100. Now this is a good example of one of the times when stopping and thinking for a second can be helpful. A lot of you know what the square root of 100 is. What times what gives you 100? And it's 10 exactly. If you know those, you don't have to do the work. Square root of 100 is 10. There's no radical left. It's not the square root of 10. It's just 10. Okay, so now I have 18 times 10 is 180. If you don't see that right away, you're going to be doing all the work over here, right? And you're going to find that if you do it right, that there's nothing left underneath the radical. Okay. Number 5, again, same like number 4, I'm going to multiply the outside stuff. Negative 6 times 4 is negative 24. We're going to multiply the inside stuff. 3 times 8 is also 24. I'm not going to worry about the negative 24 yet. It's already on the outside. I'm just going to focus on 24. It's 4 and 6. 6 is 3 and 2. 4 is 2 and 2. So I've got a pair of 2s. That's a 2 on the outside. I got a 3 and a 2 that are not paired. Those get put back together to make 6 on the inside. So now I have 2 numbers on the outside. I'm going to multiply those together. I get negative 48 radical 6. Last one. The number on the outside of the radical here is a 1. So I'm going to do 1 times 5 and say 5. 6 times 3 is 18. And now I have the 5 on the outside already. I'm going to break down 18. 9 and 2. 2 is prime. 3 and 3. Again, don't go too fast here. 3 and 3 are both a pair, so it's a 3 on the outside. A 2 is unpaired, so it's 3 radical 2. And now I've got 15 radical 2. If you're confused, don't worry, we'll get this figured out. And once you do get it figured out, it'll seem very easy. But that's the end of this video, and we'll do variables next.